Hello, and I'm glad to tell you that we are on the final stage of our journey to the detection of implicit errors that may arise during the operations of signed and unsigned. So I've got example called calculate sum, and then what this function does is that it adds up all the numbers from 0 up to the argument given, which is max here. So let's try and look at the result. For number 3, assigned to variable number, and then I'm passing it as an argument to the function calculate sum. I'll run it and see the result. It gives number 6, which is correct. And let's try for number 10. And if you add up all the numbers from 1 up to 10, it gives number 55, and it gives number 55, which is correct. However, it has an implicit error. So let's try it with number -1 and look at the result. And it doesn't give any result. And the reason is that if you remember my earlier video, when you do logical operation for signed and unsigned, the signed type is implicitly converted to unsigned. So if you convert -1 and assign, let's declare a variable max and then assign -1, and then uh, let's call printf and then look at the content in this variable max and look at the result. Actually it's not giving result because I'll calculate some up here and I'll comment this out and try again. It returns -1, and let's explicit typecast it to unsigned, and then um, see the result, and it gives this number. And if you've watched my um, earlier video, you'll know how to calculate when you do the type conversion from signed to unsigned. That has got relationship with the bit representations. And then let's look at the unsigned max for int. Umax int int max, then uint max is declared in limits the header, so I'm gonna include it, limits the header. And let's try run it and look at the result. I'll do put \n. If you look at the result given by max 42949672954, and the number given by uint max 42949672955 is the same. So what you can know from here is that when you type convert from -1 to unsigned type, it gives the largest number that you can express with unsigned in type. So what happened here, when you passed in -1 to calculate sum as a variable, this max is doing logical operation with variable I, and however, as variable I is declared with unsigned type, this max, this variable max, is implicitly converted to unsigned. So um, that is, the implicit type conversion is done to the variable max, which has been declared as signed type int. So as well as we pass in -1, this is converted to unsigned type, and then it gives the largest number that you can express with unsigned int, which is max we just saw, which was 4 to something, and it was this number, and it just loops until it reaches this number, and it worked incorrectly, and it went wrong. It actually, the code did not work as we expected, because if we pass number -1, the as max is not greater than number 0, it should not loop, because if adding up from 0 up to -1 should not be adding up all these numbers from 0 all up to this number, and it should give number 0. It should not loop. And let's um, go on to fix this problem. So although you expect that variable I uh, only variable I is only expected to have unsigned number, only the positive numbers, you should write code like this. And let's convert it to int I, and then try the earlier example that we saw before, and run it and look at the result. Uh, it's not giving. It's not still giving the result. -1. I'll try again. Now it's giving the result sum 0. So let's pass in number 3. It gives number 6. And then let's pass in number -1 again, and it gives number 0. And then let's let's change this type as unsigned to make it clear. And then let's print out the value stored in I. So if you run this, you can see that it just loops until the variable I reaches the unsigned int max. If we see more examples, let's see this if condition. I've got variable I is unsigned number 0, and in the type declared with signed type int max is assigned -1. So in this if condition, it compares whether max is greater than I, and as for now, as in max, the value -1 is not greater than I, so this condition should be false, and the statement what is in the else should be given. So let's look at the result and see whether it gives the correct result. And however, if you see this result, max is greater than I is given, and the reason is that, as we looked at before, this unsigned type and max is in signed type, so it is doing logical operation for unsigned I and signed max. And as the rule of logical operation, this signed type max is converted to unsigned. That is, implicit type conversion is done to this variable max. So it gives the unsigned the int max we saw earlier, and which was the number. Let's look at the number again, which was this much of number. I'll write it down. Um, unsigned max, this much number. So let's go to the earlier example. Let's go back to the earlier example and let's keep on going. Um, so let's try is number 1 and run this code. And as although max with number 1 is converted to unsigned type, as number 1 stays the same. So if I just go briefly, um, whether the number 1 is stored in actually if number 1 is stored in unsigned type and it does zero extension, so you can represent a number with 4 digits, 1, 2, 3, 4, and int is composed of 32 bits. And then if you pass in number 1 to um, unsigned, let's say unsigned, the leading bits are filled with all zeros. So as the number 00001 and whether it is zero extended, then this number and this number is exactly the same. However, as this int for number 1, and if it is positive number 1, then it is done zero extension. So whether it is converted to unsigned type and unsigned, it is this number and 00001 and this much number is the same. And however, if you pass in negative number in sign type, it is represented as 1, 1, 1, which is negative number -1. And as the most significant bit is 1, when you convert it to unsigned int, this it is sign extended now, and it fills in all the leading bits with ones. So it has got 32 ones, and then if you add all if you convert this binary number to decimal number, taking the most significant bit as positive number, it'll give this much of number. So as variable max is converted to unsigned, the number that is stored in max is this number, and as this becomes true, um, it will give this statement. So let's look at the result again. It gives max is greater than I. And however, if you remove this unsigned prefix for variable I, max is not greater than I. This statement is given, which is in the else condition, um, which is the correct because it just did the operation what it should do and without any implicit conversion. Um, so let's go on to this function again. And up to this point, we've um, looked at an example that may arise implicit error due to the logical operation, due to the implicit conversion that is caused by the logical operation for signed and unsigned. So um, I wanna finish off here, and from now on, you'll be able to detect problems that are caused by the logical operations when you are doing operations for signed and unsigned. So I'll wrap up here, and thanks for listening.